key questions that we're trying to solve with this machine is, if you knew what was going to happen tomorrow, would you do something differently today?
NIWA has installed one of the world's most powerful supercomputers at Gresham Point. Fitzroy, an IBM Power 575 supercomputer, allows scientists to work on complex problems of national significance. The most powerful computer of its kind in the Southern Hemisphere, NIWA's new high-performance computing facility is going to change the face of environmental, weather, marine, climate and biophysical modelling research in New Zealand. To understand the significance of this project, we have to take a look at the past. Computers were first developed by the military in the 1950s and early 60s. The 225-ton IBM Sage computer was used to coordinate early warning difference data.
Made up of radar units, early warning aircraft, weather bureau. Airmen have the battle visualized for them on the computer-generated display.
Using similar technology, meteorologists were able to make the first successful numerical weather prediction in 1950. In 1960, the first successful weather satellite, TIROS-1, was launched, demonstrating the power of satellites for weather surveying.
Two Vidicon cameras record on this magnetic tape machine, and on command send their scanning back to Earth.
The first supercomputer, a CDC-6600, was developed by Seymour Cray in 1964. Cray's key advance was to recognize that all components of the computer need to be fast, not just the processors. Meanwhile, personal computer technology was developing in parallel, but it wasn't until the early 1970s that they were affordable enough for the general public to use.
Well, I've got it here in this little briefcase. It's an original Apple I computer. Before they thought about cases for computers, this guy put it into his briefcase.
In 1972, Seymour Cray formed his own company, Cray Research, which delivered its first supercomputer, the Cray 1, to Los Alamos National Laboratory in 1976. It became the best-known supercomputer in history. In the 1980s, home computing was becoming affordable to the masses, with the likes of Apple, Commodore, Atari, and IBM.
Showing the notes that it's playing in. Okay, can you turn that off just a second?
In 1997, the power of supercomputers was again demonstrated when an undisputed chess world champion was beaten by IBM's Deep Blue. New Zealand bought its first massively parallel processor supercomputer in 1999 when NIWA installed a Cray T3E.
I measured it from the height of the false floor to the beam, and we had 50 mils clearance, not counting the bolts.
And the technology just keeps growing and growing. IBM describes supercomputers as the supersonic race car on the IT highway. Today's fastest supercomputer is more than 20 billion times faster than the Sage computer of 50 years ago. Fitzroy currently performs 34 trillion calculations per second. To understand just how quick this is, if we equate speed to distance, the IBM Sage of 1960 processed information at 75,000 instructions per second. Let's make that equivalent to travelling 15 centimetres. On the same scale, the popular Commodore 64 of 1982 would travel 1 metre, or 1 stride. The desktop PC you're using today would be around 4 kilometres. NIWA's Cray supercomputer, that was installed in 1999, would go for 1,300 kilometres, a little less than the distance from Wellington to Norfolk Island. Fitzroy would travel 67,000 kilometres, that's nearly twice around our planet, and the speed would almost double again after the planned upgrade in 2011. But aside from raw speed, what makes this system so tailored for work at NIWA is the way that the processors are connected.
Well, essentially it's a very large computer, but it's made up of a whole lot of small computers actually linked together.
But in order for that to be fast, the computers need to communicate amongst one another as fast as they possibly can. And the speed of that communication really does govern the performance of the computer.
If you think about the atmosphere, that the pressure that's happening at this point here affects what's going to happen, drives the wind and so on down here. So although we can split the problem up and send it to a lot of PCs, they've all got to work together and communicate backwards and forwards between each other all the time, telling each other what's happening in their part of the atmosphere.
The key thing that we want to do with the new machine is ensure that we can add more science into our models, that we can make better use of the observations that we take and spend a lot of money on.
Accurate environmental forecasting provides significant economic benefits to New Zealand. Regional councils, energy companies, port companies and other sectors rely on NIWA for continually updated environmental forecasts. Knowing what sort of wind or waves or rain or other environmental conditions we are going to face helps us better manage our businesses. Long and short-term climate modelling helps us prepare for the bad times and the good times.
A climate model consists of a mathematical representation of the Earth system. It tries to capture all the physical processes in the Earth system that are important for understanding what will happen in the future and understanding what has happened in the past. So they have little oceans, and they have atmospheres, and they have vegetation that can change and evolve over time. They try to capture all the important physical processes. But when we build this climate model, we break up the Earth's surface into grid boxes. And the better the computer, the smaller we can make those squares.
If you look in Europe at some of the best weather models there are, then gradually over the years their predictions have got better, and that's because they have used bigger computers, better models and data assimilation. So we expect our results to actually reflect the same sort of benefits, the same sort of improvements that have happened overseas.
The key problems that we're interested in are ones relating to fluid flow, so that's in the ocean and the atmosphere. But there are other organisations like the Bioengineering Institute at University of Auckland, and they are solving problems to do with understanding how human organs work. And ultimately, they would like to understand how, if you give an organ a particular drug, how it will respond. Another possibility are people who are interested in earthquake simulation, where you're trying to understand what's happening in the four-dimensional space at the time of an earthquake.
The build of NIWA's high-performance computing facility began in early 2010. After the 2011 upgrade, Fitzroy will be housed in 17 racks. The racks will contain more than 5 petabytes of magnetic tape storage, 2 petabytes of hard drive storage, 3,456 processors, and 8.7 terabytes of memory. Fitzroy is one of the most significant advancements in climate and natural hazards research New Zealand science has seen. It is the most powerful environmental forecasting supercomputer in the Southern Hemisphere. Who knows what discoveries will be made?